Hi everyone, today let's talk about section 2.5, limits and infinity. So last time we talked about section 2.4 and we will introduce vertical asymptotes. So in this session today, we're going to talk about horizontal asymptotes. So here is the definition. If f of x becomes arbitrarily close to a finite number L for all sufficiently large positive x, then we write the limit x goes to infinity, f of x equals L. And the picture, it could be like, you can see when x goes to infinity, our y is getting close to a constant number, L, right? And we also have this picture and this picture. So you can see our function can cross the line, okay? It can cross the horizontal line. And it can cross it as many times as we want. However, for vertical asymptotes, we're not able to cross the vertical asymptotes, okay? And similarly, if f of x becomes arbitrarily close to a finite number L for all sufficiently large negative x, then we write the limit x goes to minus infinity, f of x equals L. So you can see when x getting close to minus infinity, and then our y is approaching a number. Okay, so in these cases, the line y equals L is a horizontal asymptote. Okay, so I also want to make a comparison with you. So, let's compare the vertical asymptote and horizontal asymptotes. Okay, let's talk about the number. How many vertical asymptotes can we have? Well, we can have 1, right? We can have 0, of course. We can have 1 vertical asymptote. We can have 2. And actually, we can have as many as we want. Infinity, right? Because think about the tangent x. The tangent x is a periodic function. We have infinitely many vertical asymptotes, right? So that's why the number of vertical asymptotes could be infinity. However, the horizontal asymptotes, we can have one horizontal asymptote as x goes to infinity. We can have another one when x goes to minus infinity. So there are at most 2 horizontal asymptotes. So the number of horizontal asymptotes can be 0, 1, or 2. So at most 2. Okay? And how about the vertical asymptotes? Can we cross the vertical asymptotes? No. We can cross it. Okay, so maybe we can have like a picture. This side we have the vertical asymptote. On the other side we have a dots right here, but we're not like they're not connected together. We're not like crossing it. If we're crossing the vertical asymptote, then this is not a vertical asymptote. Okay. So, and this is because it has to be a function. So there can only be 1 point at that a value. Okay. Alright, so we cannot cross the vertical asymptotes. But however, for horizontal asymptotes, we can cross it as many times as we want. Look at this picture. Okay, we can cross it so many times. So here we can cross it. Okay. So, and then how do we find vertical asymptotes? We're looking for when x approaching a finite number, either from the right or from the left, and we want to see if that is infinity or minus infinity. Okay, if this happens, then we have a vertical asymptote. So when do we have a horizontal asymptote? Well, the x is not going to a number. It's going to either positive or minus infinity. And we want to have the limit equals a number. Okay? So the y is approaching a number when x goes to infinity or minus infinity. So you can see here, for vertical asymptote, the x is a number. The y is infinity. For horizontal asymptote, the x is infinity, the y is a number. So they kind of flip, right? So, and last, vertical asymptotes, they are vertical line. Okay, so lines, what is lines? Line is equation. It's not a number, it's an equation. Okay, and horizontal asymptotes, they are horizontal lines. So y equals L. These are horizontal lines. Okay, so this is a small comparison between vertical asymptotes and horizontal asymptotes. Okay, so let's see. How do we find the horizontal asymptotes? So let me review with you. How do we find vertical asymptote from the last class? Okay, so I'm also comparing the steps with you. Okay, so here are the steps. How do we find vertical asymptote and how do we find horizontal asymptotes? So a lot of students get confused about the steps. So that's why I decided to write down the steps here. Then you can, from this comparison, you can know the difference between them. Okay, so what are the steps? Do you remember? First, we want to factor. Okay, and then second, we want to figure out the domain. And then 3 for each point outside of your domain. Okay, so for each point outside of our domain, we want to check the limits. Okay, so we usually check the right side of the limits. If this guy is infinity or minus infinity, then we have the vertical asymptote is x equals a. Okay, and if the two-sided limits, okay, to show no vertical asymptote, okay, we need the two-sided limits. If this guy is a number, okay, a number which is not infinity or minus infinity, then we don't have a vertical asymptote there. Okay, so here we need the two-sided limits to show no vertical asymptotes. Okay, so how about horizontal asymptotes? Well, horizontal asymptotes, first step, don't factor it. We don't want the factor form. We want the polynomial standard form, right? The general form. So don't factor it. And what do? We want to look at the dominant terms. Okay, if it's usually you will get a quotient. Okay, so we look at dominant term of numerator. Okay, so dominant term of numerator. And we look at dominant term of denominator. Okay, so dominant term of denominator. Okay, and second steps, we want to compute the limit x goes to infinity, f of x. And we also want to compute x goes to minus infinity of f of x. And if we get a number L, well, what does that mean? That means the horizontal asymptote is y equals L. If we don't get a number, so if we get infinity or minus infinity or the limit does not exist, then we don't have any horizontal asymptotes. So no horizontal asymptotes. So here are the steps. So far, so good, everybody. Okay, let's continue and solve our example 1. So for a problem in the exam, you will see, I will give you a function like this, and I will ask you to find all the vertical asymptotes and horizontal asymptotes. So you're going to do this differently to find them. Okay? So our first steps. Well, okay. Remember, don't factor it. We look at the dominant terms of the numerator. Well, here, what are the dominant terms of the numerator? Dominant terms is the highest power. Think about it, when x goes to infinity, the highest power terms dominant. Think about it. If you have $1 million, do you care about a penny? Yes. But maybe not that much if you only have 10 cents, right? If you have 10 cents, you care about the penny much more than if you have $1 million, right? So, that's why it's enough to just look at the dominant terms, the highest power term of the numerator and denominator. Okay, so here I'm gonna show you a complete proof, and then I want to show you the quick way that you can do it in our course. Okay, so the formal proof for this kind of problems is, well, you want to compute x goes to infinity, right? 4x squared minus 13x plus 3, 2x squared minus 5x minus 3. So what do? Well, you're gonna divide the numerator and denominator by the highest power term, so which is x squared. Okay, so you can see the degree of the numerator is 2, the degree of the denominator is also 2. So let's divide it by both divided by 1 over x squared. Sorry, divided by x squared. So multiply by 1 over x squared. And then you distribute. So when we distribute, what happened? Oh, we get 4 minus 13 over x plus 3 over x squared. And the bottom we have 2 minus 5 over x minus 3 over x squared. Now, when x goes to infinity, remember a constant over 0 plus is infinity, constant over 0 minus is minus infinity, but 1 over infinity is actually 0. 1 over minus infinity is also 0. So all these guys, they go to 0. So that's why here we just get 4 minus 0 plus 0 over 2 minus 0 minus 0. So 4 over 2, which is 2. So this is the formal proof. Okay, so but in our course you can do the shorter proof. Okay, so this is the proof. Okay, so this is the shorthand way. Then you can use this in your exam or homework. Okay, so what do? Tell me, what is the dominant term of the numerator? Well, the dominant term of the numerator is the highest degree term in the numerator, which is 4x squared. What is the dominant term of denominator? Dominant term of denominator. Well, that is the highest power terms in the denominator, which is 2x squared. And then so our limit x goes to infinity, f of x, well, it's enough to just look at the dominant term of the numerator over the dominant terms of denominator. Then x squared cancel. We have 4 over 2, which is 2. See, it's a shorthand way to do that. Okay, so in the exam you have to, you can use this way. But if you use this shorthand proof, you have to write down what is the dominant terms of numerator and what is the dominant terms of denominator. Okay, if you don't write those down, you get some points off. Okay, so make sure everybody is clear about my requirements. If you use the shorthand way, you have to write down dominant terms of the numerator and dominant terms of denominator. Okay, so because the limit x goes to infinity, we get a number, so we actually get a horizontal asymptote that is y equals 2. And we also need to check the other side. Well, but you can see the other side is just gonna be the same thing, right? So we still have 4x squared over 2x squared is still 4 over 2, which is 2. So we will have the same number. So actually, for this example, both sides will have the same horizontal asymptote, which is y equals 2. Okay, so this is the first example. And is that possible that we have two different horizontal asymptotes? Yes. Let's see this example too. We'll see that we're gonna have two horizontal asymptotes, and we can see what actually can make this happen. Okay, so we're gonna use the quick way from now on. So dominant term of numerator, what is that? Well, 4x, right? Dominant term of denominator. Okay, which one is the highest degree? Well, this is square root of x squared. So it's like degree 1, right? So degree 1 is the dominant terms. So what are all the terms with degree 1? Well, this guy, this is not degree 2. Be careful because you're taking square root of square. So it's like degree 1. And there is another term with degree 1. So this guy and this guy. So don't forget them. Okay, what is square root of 9? That is 3. And then do you know what square root of x squared? Is this x? No, this is actually absolute value of x. Okay, so this is absolute value of x. Well, absolute value of x depending on whether x is positive or negative. It's going to be different things. First of all, absolute value of x is always positive, right? So if x is positive, then absolute value of x is just x because x is positive, right? But if x is negative, well, if x is negative, minus x will be positive. So absolute value of x is minus x. If you think this is quite abstract, you don't quite get it, think about, let's do some numbers. Okay, what's absolute value of 2? Well, 2, right? What's absolute value of minus 2? Well, 2, right? Absolute value is always positive number. But what is 2? 2 is like negative of negative 2. So because negative 2 is negative, so you have to put a minus sign in front of it to make it positive. That's why you have minus x. Okay? So here you actually get 3 times absolute value of x plus 7x. Well, then you have to think about whether x is positive or negative. If x is positive, well, then you just get 3x plus 7x, which is 10x, right? But if x is negative, then you have minus 3x plus 7x is gonna be 4x. So far, so good, everybody. Alright, then we're ready. Limits x goes to infinity of f of x. Okay, because x goes to infinity, well, that means your x is positive, right? And then, because it's positive, what's the dominant term of numerator? Oh, always 4x. What is the dominant term of denominator? Well, now it's 10x. Wow, x can cancel. Then we have 4 over 10, which is 2 over 5. So far, so good, everybody. And how about on the other side? Well, in this case, x is negative. So when x is negative, the dominant term of numerator stay the same, but the dominant terms of the denominator becomes 4x. Okay? And you can see x cancels, so 4 over 4 is 1. Okay, yeah, you gotta cancel the x because infinity over infinity, oh, we don't know what that is. So you want to simplify it and then you can plug in. So far, so good, everybody. Alright, let's continue. Oh, not yet. So because both sides we have no numbers, so horizontal asymptotes are y equals 2 over 5 and y equals 1. So we have 2 horizontal asymptotes. Okay, let's continue. So limits, infinite limits at infinity. If f of x becomes arbitrarily large as x becomes arbitrarily large, then we write the limits x goes to infinity, f of x equals infinity. And the other limits can be defined similarly. Alright, so, Okay, so what's the picture of this guy? Well, you think about this picture is like this, right? When x goes to infinity, f of x also goes to infinity. Well, how about this picture? When x goes to infinity, f of x goes to minus infinity, so like that. And this picture, when x goes to minus infinity, f of x goes to infinity, so like this. This guy, when x goes to minus infinity, y goes to minus infinity, so go to the left and go to the bottom. So like that. Okay, and here we're gonna see a table. So here is the end behavior of different functions. First, let's look at polynomials. So let n be a positive integer, and let p be the polynomial where the leading coefficient a sub n is not 0. Okay, so if n is odd and the leading coefficient is positive, well, then let's think about an example. Well, n is odd and the leading coefficient is positive. Well, we can think of the easiest example is like x cubed. Right? What's the picture of x cubed? I hope you all remember. Okay, so when x goes to infinity, what happened to your y? Your y also goes to infinity, right? So that's why limits x goes to infinity, p of x is infinity. How about when x goes to minus infinity? Your y goes down, right? So that's why you have minus infinity. Okay, if n is odd and a sub n is negative, well, what does that mean? Well, you think about negative x cubed is kind of flip this across the x-axis, right? Then when x goes to positive infinity, y actually goes to minus infinity. And when x goes to minus infinity, the y goes to infinity. Okay, how about when n is even? Well, you think about example x squared, right? What's the picture of x squared? Like this. So when x goes to positive infinity or minus infinity, the y goes to infinity. How about when the leading coefficient is negative? We can think about minus x squared. So it is kind of flip it down, right? So then no matter whether x goes to infinity or minus infinity, the y goes to minus infinity. And because the limits, we don't get a number, so we don't have any horizontal asymptotes in all of these cases. Okay, so that is for polynomial. Next, rational functions. Suppose f of x equals p of x over q of x is a rational function where a sub n and b sub n are not 0. So those are the leading coefficients. Okay, then we look at the degree. So m is the degree of the numerator. And n is the degree of denominator. Okay, think about if the degree of the denominator is bigger. Well, you have the denominator bigger. Of course, your denominator bigger, then the number is getting smaller. That's why the limit is 0. In this case, we have a horizontal asymptote y equals 0. Well, if they have the same degree, right? If they have the same degree, well, see, we just look at the dominant terms. If they have the same degree, well, then m and n are the same. The x just cancel out, and then we only have the ratio of the leading coefficients. So far, so good. So then we have a horizontal asymptotes, y equals the ratio of their leading coefficients. If the numerator has a bigger degree, wow, then your numerator bigger, so the number is gonna be bigger. So it's either infinity or minus infinity. In this case, we don't have any horizontal asymptotes. Okay, and furthermore, assuming that f of x is in the reduced form, so p and q share no common factors. So which means you factor out the p and q and you cancel the common factors, and then vertical asymptotes occurs at the 0 of the denominator. Well, remember, even though we know that But in the exams, you still need to show all your work, okay? So you need to find a domain. Even though for some of the factor you know you're going to cancel it and it won't contribute to the vertical asymptotes, you still need to compute the limits and show that limits equals a number. Then we don't have a vertical asymptote there. So I want to make sure you understand the requirements, okay? Don't miss the steps. Each step has some points in your exams. Okay, that's very important. Next, exponential functions and logarithmic function. So here we have the exponential function. So it's an increasing function, right? And so that's why when x goes to infinity, we see y goes to infinity. And when x goes to minus infinity, the y goes to 0. So that's why we have a horizontal asymptote y equals 0. How about e to the minus x? Well, you just flip it across the y-axis, right? It's a decreasing function. So now when x goes to infinity, y is going to 0. And when x goes to minus infinity, y approaches infinity. Okay, so in this case, we also have a horizontal asymptote y equals 0. And how about natural log of, the logarithmic function, natural log of x, okay? Oops. So do you remember inverse function? So natural log of x is the inverse function of e to the x. So how do we draw inverse function? We flip it across the line y equals x, right? This guy, flip it over, and then you get this guy. So they're inverse function. And now you can see when x goes to infinity, natural log of x goes to infinity. When x goes to 0 from the right, we get the natural log of x goes to minus infinity. So in this case, we don't have any horizontal asymptotes, but we do have a vertical asymptote. So the vertical asymptote is x equals 0. So far, so good, everybody? Okay. And for the trig functions, well, for sine and cosine, I hope you can remember sine and cosine. So this is sine. It starts with 0 and then oscillating, right? This is sine. And cosine start with 1 and then oscillate. And then the tangent is the tangent is the black lines, right? And the cosine is 1 over tangent. So that's why we flip it over, okay? The orange line is the cotangent. You can see they don't, so all of these trig functions, we don't have horizontal asymptotes. And but for tangent, cotangent, we do have vertical asymptotes. The vertical asymptotes for tangent is pi over half, so pi over 2 plus k pi. And the vertical asymptotes for cotangent is k pi. And similarly, we have vertical asymptotes for secant and cosecant. So secant is 1 over cosine. So how do you draw the secant? Well, you flip the cos. Okay, you know it's 1 over cosine, right? So the cosine is right here. So 1 over 1 is 1. 1 over 0 is going to be infinity. That's why you like flip it up, okay? So that's the secant, and as well, the cosecant is 1 over sine, okay? And here are all of their vertical asymptotes. It's actually just the domain. If you find a domain, okay, domain cannot be those numbers, and those numbers are exactly the vertical asymptotes. Okay, so right now, let's work on more exercise. Okay, so let's look at this one. And so remember, we always going to do the quick way. What is the dominant term of the numerator? So numerator is going to be this guy, but because it's multiply, so you also need to include these terms. So 10x squared times 3x. Well, that is 30x cubed, right? And how about dominant term of denominator? By the way, I strongly recommend you to stop the video and try those problems first, and then continue to watch a video and check your answers. Okay, so this is the highest power. Don't forget the square root. Then we have square root of 25 is 5. Square root of x to 6 is x cubed, but absolute value. Okay? Remember, if you have absolute value, square root of x to the even power, you're gonna expect to see absolute value of x to that even power divided by 2. Okay? So this is the place you may have, two different horizontal asymptotes. Okay? So when do you have horizontal different when do you have two different horizontal asymptotes? Well, that is when you see square roots of x to the even power. Okay, so that's why here when x is positive, greater or equal to 0, we get 5x cubed. But when x is negative, we have minus 5x cubed. Okay, so limits x goes to infinity. What do we get? F of x. So I don't want to copy the whole thing, so I can just say f of x. The dominant term of numerator, 30x cubed. The dominant terms of denominator, because when x goes to infinity, x is positive, so we take 5x cubed. X cubed cancel. 30 over 5 is 6. Okay, how about on the other hand? Oops, negative infinity, right? Let me write it better. Okay, so dominant term of numerator stay the same, but the dominant term of denominator becomes negative 5x cubed, and x cubed cancel, we have minus 6. So horizontal asymptotes are, don't answer 6 and minus 6. Horizontal asymptotes, they are horizontal line. So y equals 6 and y equals minus 6. And don't answer x there. They are y, horizontal lines. Okay? So this is the complete proof of our example 3. Let's continue and look at example 4. So what is the dominant term of numerator? Is it this guy? Let me ask you. This is cube root. This is a square root. Which one? Which one dominant? The square root, right? Actually, this problem is quite tricky because the square root's dominant, not the cube roots. Okay? And dominant term of denominator is negative 9 square root of x. Okay? You also need to include the coefficient term. What is the term? Term is separated by plus and minus sign. So you also need to include the minus sign and the coefficients. Okay? It's not a single factor of a term. It's a term. Okay? And then, furthermore here, when x goes to infinity, f of x, you can see, actually here, because of the square root, the domain, your x must be greater equals 0, right? So that's why we will have, the case, when x goes to, let's see, when x goes to infinity, but we won't have the case when x goes to minus infinity. Okay? Alright, so that's why here limits x goes to infinity, dominant terms minus square root of x. This is minus 9 square root of x. They cancel, this cancel. We get 1 over 9. So horizontal asymptote is y equals 1 over 9. And that's it. We don't need to mention x goes to minus infinity because x must be greater or equal to 0. So far, so good, everybody? Okay, so let's continue. Okay, all right. Okay, so what is this guy? Well, so here you can see the power inside the square roots is an add power. If it's add power, then it's like square root of x. Then you require the things inside the square root to be greater or equal to 0. So if it says that your x can only be positive infinity, so x cannot go to minus infinity. Okay, so be careful with that. So that's why if you have square root of x to the odd power, then you only expect the x can only go to infinity. So at most one. So at most one horizontal asymptotes. But if you have x to the even power, well, x can go to so this is absolute value of some power. So x can go to either positive infinity or minus infinity. Then we may have 2 horizontal asymptotes. Okay, so dominant term of numerator is this guy with square root of 2 and square root of x fifth. I strongly recommend you to separate the coefficients and the powers of x. Well, this is it 1/5? No, 5/2. Okay. So, and then dominant term of denominator, this guy, square root of 3, and x to the 5/2. Okay, limits x goes to infinity, f of x is then limits x goes to infinity of square root of 2, x to the 5/2, square root of 3, x to the 5/2, and they cancel square root of 2 over square root of 3. I know it's not a fraction. I mean, it's not a rational number or integer. Okay, sometimes your answer can be like not a nice number, but it's okay. It's still a number. So horizontal asymptote is y equals that number. So far, so good? All right. So let's continue. Example 6. Example 6. Here, when x goes to infinity, well, we look at the quotient inside of the sign. Okay. So what is the dominant term of numerator? X. What's the dominant term of denominator? 6x squared. So this guy actually goes to x over 6x squared. Well, x cancel because you're looking at limits x goes to infinity. This is 1 over 6x because you have constants over something goes to infinity. This will be 0. And then finally this guy is gonna be the limit because the things inside the sign goes to 0. So this guy is like sine of 0, which is 0. Okay, so this is the limit. So far, so good, everybody? Okay, next, let's continue. Well, when x goes to infinity, here my sign is oscillating between -1 and 1, +1, still oscillating between two numbers, and the denominator is getting close to infinity. Well, do you remember last time we talked about, when we see sine multiplied by some power function, or cosine multiplied by some power function, what theorem did we use? Yes. Squeeze theorem. So squeeze theorem, you always start with the sine or cosine term. I have sine 5x here, right? So just look at the problem. You start with the sine term. So sine 5x. Bounded between -1 and 1. Then you add 1 to each of the terms. So you add 1 to each of the terms. This guy becomes 0. This is 1 plus sine 5x. This is 2, right? So by the way, adding a number or subtracting a number won't change the inequality sign. Okay, so next, how do we get to our formula? We divide it by square root of 1 plus x. 0 divided by anything is 0. And 2 over square root of 1 plus x. And because the square root of 1 plus x is a positive number, so you don't need to worry about like flipping the inequality. Okay? And now, oh, this guy is always 0. This guy, the limit x goes to infinity. Oh, what happened? You have a constant over something goes to infinity. So constant over infinity is 0. Oh, nice. The left side is always 0. The right side, we have the limits getting close to 0. Then we say by squeeze theorem. So THM is for the theorem. Okay. Then the limits of the middle guy is also 0. Okay, so this is the complete proof. So think about squeeze theorem when you see sine, cosine, and multiply by some power functions. Okay, alright, so not necessarily power function. It can be a lot of function. Okay, so let's look at this one. Think about sine, cosine, always bounded between two numbers. And now, when x goes to infinity, your denominator is getting close to infinity, right? So let's do squeeze theorem again. Start with the cosine term. I know this cosine term looks complicated. It's okay. Just copy it down. By the way, this whole thing is inside of the cosine. Okay? So it's not like cosine. So that's why our baby parenthesis is so important. If the parenthesis close here, it means then this is cosine 7 cube root of x plus 100, but we're not. We have the parentheses here. So everything is inside of the cosine. So be careful with that. So this guy is bounded between 1 and minus 1. And then how to get to our formula? We divide each term by e to the 3x. And because e to the 3x is always positive, that's why we don't need to change the inequality. Okay, now we're ready. Limit x goes to infinity. Okay, so we have constants over something goes to infinity. Well, that is 0. And on the other side, we have constants over something goes to infinity is also 0. That's why we say by squeeze theorem, the middle guy has the same limits. Okay, you see different problem, but they are of the same kind. The steps are the same. You bound it between minus 1 and 1, and then you see how to change to your formula, and then you compute the limits of the left boundary and the right boundary, and then you show them they have the same limits. Then by the squeeze theorem, the middle guy must have the same limits. So far, so good, everybody. All right, let's continue. Example 9. We want to find the limits about two functions. Okay, so we have two functions. Let's see. First, remember when we compute the limits, the first step we try to plug in and to see whether we can come up with an answer. So here, when we plug in, we have infinity minus infinity, right? Oh, do we know what that is? No, we can't tell. Okay, but when x goes to minus infinity, well then x squared becomes positive infinity and the square root is still positive infinity. So it's positive infinity minus of negative infinity. Well, this is infinity plus infinity. Can we tell what is infinity plus infinity? Yes. That is infinity. So for the second limits, we are good already. We know it's infinity. But for the first limits, we don't know. Okay, do you remember when we see difference of square roots, what do we do? we multiply by its conjugate, right? We multiply by its conjugate. This is the conjugate, right? So what happened to the conjugate? Wow. So what is good for the conjugates? Remember a minus b times a plus b is a squared minus b squared. So it actually helps us to get rid of the square root. Okay, so that's why this guy equals the first guy squared, which is x squared plus 4, minus the second guy squared, so x squared. And then over square root of x squared plus 4 plus x. Now what can we cancel? Wow, x squared cancel. So we have the limits. X goes to infinity. 4 over x squared plus 4 plus x. Okay, now we see the dominant term of numerator is just 4. But dominant term of denominator is, what is the dominant term? Well, square root of x squared is like degree 1. And x is degree 1. So that's why we have square root of x squared and x. Okay, now this is absolute value of x plus x. But because here we are looking for x goes to infinity, so x is positive, then absolute value of x is just x. Well, so we have 2x. 2x is our dominant terms in the denominator. Then this guy equals limits x goes to infinity, 4 over 2x. Well, we have constants over some number goes to infinity. Well, that is 0. So this is the limit of this guy. Okay? So far, so good, everybody. So you can see, even though we have the same formula expression, but the limits when x goes to different number, infinity or minus infinity, the answer can be totally different. So when you read the problem, really carefully, where is your x approaching? Okay? So let's continue. So continue on example 10. So example 10 is right here. Can you see it's so similar to example 9? But we just have an extra x. How would this x change to it? So first of all, you get infinity times infinity minus infinity. So we still don't know what is that. So that's why you still need to multiply by the conjugate, okay? Because it's quite almost the same with the last problem. I'm just like try to be lazy and copy it right here. Oops. So let me delete that. Okay, what is new now? I'm gonna use a different color so you can see the difference. I'm gonna use the blue line. Okay, so what is new now? We have an extra x right here, right? So we have an extra x right here. And what does this change? Well, here is almost the same, but we have an extra x right here. Okay? And then here we're going to have an extra x right here. So the dominant in terms of the numerator is 4x. So here we have 4x. Oh, see what happened? X cancel. We have 4 over 2. We actually get 2. So we don't get a 0 anymore. We have 2. So this is the difference between example 9 and example 10. Okay? So far, so good. So if you want to remember when you're watching the videos, you can control your pace. So feel free to pause it and think a little bit more, okay, and try to understand each step. And you can also replay the video again and again. And when you have questions, feel free to print screen and ask me. Okay, example 11. So here we want to sketch the curve. Okay, so how to sketch a possible graph of a function f such that it satisfies all the given conditions. Be sure to sketch all the vertical and horizontal asymptotes, if there are any. Okay, so we want to use those information and we want to sketch the graph. So let's see. Let me use the black one. Okay. So this is the x-axis. This is the y-axis. Okay, so now let's draw for each information. Well, this information, what does it tell us? Well, see this is the x value and this is the y value. It tells us when x equals -1. So remember, some of you don't draw the number, just put the scale. No, everybody, you must put down the number as well. So don't just draw the scale there and without indicating what is that. Okay, so please write down the number. So this is -1. And y is -2. So -2. You don't need to write down all the number for the scale, but for the important points, important information, write down the number. Okay, if you don't write down the number in the exam, I will take points off. So be careful. I want to make sure you know my requirements. Okay, so this information tells us this point. Okay. And this guy, next information, x is 1. So 1 is right here. Y is 2. So we're at this point. So this is the second information tell us. And then the third information, f of 0 is 0. Okay, well that is the origin, right? So the origin, we have 0 is 0. Okay, so right here. Okay, and so we have 3 points now. Next, the limit when x goes to -infinity. Where is -infinity? Right here, right? This is -infinity equals -1. Oh, so which means we're approaching to the y. The y is approaching to -1 when x goes to -infinity. Well, so all of the information, you want to draw a little pieces. So you want to draw a dots. So the dots could be either above or below. We'll see which one make more sense. Okay, and then the next information, when x goes to infinity, the y is approaching 1. So 1 is right here and we have a dashed line there. So how do we approaching the line? We can approaching from the top or the bottom. So let's draw a 2 small dot there and we will see which way it make more sense when we connect all the dots together. So now we have put down all the information. We can connect the dot together. So when you connect the dot together, start with the origin. Start with the center, okay? The region near the origin. So we have 0 at the origin, and then let's go to the right. We connect this dot together. So that's why we have this guy. And then we want to connect this one with one of the dots there. So I would say probably the top dot is more make more sense. So we can connect the top dots, okay, smoothly. And then on the left, we connect them here and then connect the bottom dot together. So this is the graph, okay? So first, for each information, write down the dots. Make sure what is your x, what is your y. And then when you connect all the dots together, you starting from the center. And then you go to the right and you go to the left. Okay, so let's do one more example. So this example has more information, so it's a harder one. So your exam is going to look like this problem. Okay, so let's draw the x-axis and the y-axis. And then let's look at each information. Well, the first information, when x goes to -infinity, so -infinity is on the left, and then the y is 3. Where's the 3? Well, 1, 2, 3. 3 right here. Okay, so we're gonna have a horizontal asymptote here. And then there's two ways we can approaching it, either from the top or bottom. Okay, and then second information, f of -3 is 1. So x is -3. Okay, remember for the important points, write down the number. And the y is 1, so which is this point. Okay. Next information, x goes to -2. -2 is right here. Okay. I think I should draw my, I want to draw my picture bigger enough then you can see it. So let me redraw it bigger so then you can see it better. Okay. Let me see. Okay, let me just redraw it. Okay, so I want to draw it bigger. So -3, so 3, 1, 2, 3 right here. So we're either approaching from the top or bottom, and then -3, 1, 2, 3. And the y is 1. So we're at this point, okay? And then next, -2 right here. From the left or right. So negative means from the left. So here, we're gonna have -infinity. Wow, we know then we're gonna have a vertical asymptote here. So we are from the left, -infinity goes down. So which is here. Okay, it's on the left-hand side of the point -2 and it's in the bottom. Okay, how about this information? We're approaching -2 from the right. So it's the right-hand side and is -infinity also bottom. So we draw this point right here. Okay, so far so good. So you have to be careful, is approaching from the left side or right side, top or bottom. There are 4 possibilities. So make sure you know which one. And then next goes to 1. So 1 is right here. And then left. So because we have a -infinity, we're gonna know we're gonna have a vertical asymptote here. So from the left and -infinity, so bottom, which is this dot. Next information, approaching 1 from the right. Oh, past the infinity, so it's top. So we put the dots right here. Okay, and then next information, f of 5. Where is 5? 1, 2, 3, 4, 5. F of 5 is -2, 1, 2, -2. Okay, so we're at this dot. Okay, and then eventually when x goes to infinity this direction, y is -1. Oh, so we have a horizontal asymptote there. We can approaching it from the top or bottom. So here we have 2 possibilities. We don't know which one. So let's put both of them. So everybody, for horizontal asymptotes, you can have 2 possibilities, so we put it there because later on when we connect the dots, we're gonna choose which one will make our graph more pretty. Okay, so remember we're drawing a functions. So functions should pass the vertical line test. Each vertical line should only intersect the function at most once. Okay, so okay, now we connected all the dots together. So in the center, we don't know whether it passed through, so we don't have restriction there, so we can just connect those 2 dots together like this. Okay, because it doesn't say it must pass through the origin, so we can just do something like this. Okay, and then on the left, you can see I connect this dot with this dot, and maybe the bottom dot make more sense, so I'm gonna connect the bottom dot. And then on the other picture, I connect this guy. Oops. Make sure you pass through it. And then connect this bar. And then I would say the bottom dots make more sense. I connect the bottom dots. And then I can erase the top dots. So now you can see my picture. I connect all the dots together. And make sure you pass through the vertical line test. So this is a function. Don't draw 2 pieces over there. this is not a function because you pass the vertical line twice. This is not a function. So we need to have a function. Okay, so I hope you can like create more information and try to sketch a graph that satisfy all the information. Okay, so the tips is you figure out which one is x, figure out which one is y, and for the vertical asymptotes, you have 4 possibilities going from the left or right, top and bottom. Then you read the problem carefully and make sure which dots, okay? And then you connect the dots smoothly. Feel free to email me if you have any questions. Have a nice day. Bye.